soar, use your own AI, we'll explore. Help the future hand in hand in this tech-driven wonderland.
Okay, hello everyone. It's a new episode of NEAR Office Hours. Today with us is Johannes from Prime Intellect. I only learned about Prime Intellect last October when you guys started training Intellect 1. And mostly what I knew was that you're training a large model using DLOC, but I've been reading up in the last couple of days leading to this office hours, and I don't know how we're going to squeeze all of that into 1 hour. That's a lot of exciting things that there are to discuss. Do you want to give a quick intro on yourself and Prime Intellect?
Yeah, for sure. Happy to do it. And yeah, nice to meet you, Alex. So yeah, I'm Johannes, one of the co-founders of Prime Intellect. And yeah, my background is more on like the AI side. So I've been training foundation models at a foundation model app here in Europe since end of 2021. And yeah, basically what we do at Prime Intellect is we aggregate global compute resources from all providers, all data centers, and have them all in a single platform, as well as working on training distributed across all those different clusters. So we are making working on fundamental research to make distributed training work and scale. And obviously had the Intellect 1 launch where we actually scaled up our research that we've been doing since end of last year, basically. To the 10 billion parameter size, and from here on, want to scale it up further, obviously, and generally are interested in all types of research directions which are important to make open source AGI a reality. So not only on the decentralized training side, which will be one important part to make large scale compute resources available, obviously, but also all other research directions from large scale synthetic data generation to obviously not just training a pre-trained model, but also maybe going more into this test and compute direction.
Yeah. Okay, so I suggest we begin with the lowest level and go up,
Sure.
climbing up the master plan, right? So the first step was to pool the compute, and that's something that many companies do, right? Like there's a cache network, exhibits, hyperbolic. So my understanding is that Prime Intellect is sort of orthogonal to all of them, right? You're not trying to compete with them. You're trying to take advantage of all of them. I saw Hyperbolic was participating in training of Intellect 1, right? So how do you see the role of Prime Intellect here, and how does it work with all of those?
On the aggregation side, I would say we are a bit on a layer on top in a sense, right? Just by being more like a compute exchange, right? Like having all those providers on the platform basically, and letting people tap into the cheapest compute resources through it, right? So we have a bunch of the centralized new cloud providers on the platform, which have varying availability, right? Often it's been a joke over the last couple of years, right? That Lambda Labs didn't have the H100s available to train your AI models or something like this, right? But somebody else might have it, right? And that's the approach we've been going for there, having more of a compute exchange, basically. You can always tap into the cheapest compute resources. And obviously, we aggregate all of the providers, right? From the Web2 players to also more in Akash, for example, is on our platform. We have an easy interface to make use of it, and just give more access and cheaper compute to open source AI developers.
Right. And so my understanding is that the interface with the provider, right, is that they give you an SSH access, right? You SSH to the machine, do whatever you want, right? And there's naturally, if you think about it on a very high scale, right, it's there's certain trust that needs to be between you and the provider, right? That they will not, give you inferior hardware, pretending it to be superior hardware and whatnot. So right now, there is no attempt to fix that problem, right? We just assume that if they give us a machine with 8 H100s, then it's a machine with 8 H100s, right?
Yeah, in a sense, right now we rely a bit on the provider in a sense, right? Obviously, we make it easier for people to know which one is a trustful provider in a sense, having community cloud offerings and a secure cloud offering. The other thing is, it's not only about like trust or like trustless compute in that sense, right? It's also like reliability of a provider, right? Especially if you're an AI researcher and want to scale up things, yeah, to more than an H100 node, for example. There's yeah, a lot of considerations basically that some of the providers fail way more often than the other ones, right? So there's been some interesting reports of that in the Llama 3 paper and so on, right? That yeah, how reliable different providers are, right? So yeah, I think that's another component, right? Those two, reliability of the provider as well as yeah, can you trust that compute resource? Is it actually giving you an H100, right? So yeah.
Yeah. Okay. And so, like, the next step of the master plan was to build Prime, I guess it's called, right?
Yeah,
I don't know if it's a transformer implementation, right? And Optimus Prime is a transformer. I don't know if that's intentional or not. But
do you know where the name Prime Intellect is coming from?
no, I don't know. Where is it from?
There's a nice sci-fi book about it, basically, about like an ASI that's called Prime Intellect. That's where the original name is coming from. Yeah.
Yeah, I'm reading ungodly amount of science fiction, but I haven't heard of that one yet. So I'll be sure to read it. Is it a good book?
I'm gonna get cancer for it. No. It's definitely interesting in a sense. I don't agree with the whole conclusion, obviously there, but it also paints an interesting ASI future where everybody has everything, everybody is immortal in a sense, but they also don't have anything to do in a post ASI world.
It was not a yes. It's yeah, but so I saw. So there was a paper, right? You first published the Open DLOC paper, and then there was a technical report later, I guess very recently, right? And technical report has more things, right? There's FSDP and whatnot. So I guess let's dive into all of those. So let's begin with DLOC, right? Can you give us like a quick overview of what DLOC is and why it is needed?
For sure. Have to give like a timeline there basically. So end of last year, it's a work by Google DeepMind called distributed low communication training, which is basically a technique they've published for doing distributed training with relatively low communication requirements. So they have they train their models on different islands of devices basically, and then usually how you have to do it in your distributed training setup, you have to sync after every step in your training, basically. So every step you have to send quite a bit of data, basically, of the gradients in like an all reduced fashion. And in this paper, they basically showed they could get the same performance out of it by only syncing every 500 steps. And yeah, are training independently for about 500 steps on each of those machines, and then they sync between those and do an auto optimization loop basically to still achieve the same performance as you would get in your centralized training setup. And maybe to go to OpenDLOC basically for the timeline there. So we started reproducing that DeepMind work at the beginning of the year. So I think in April or May or something like this, we launched OpenDLOC, which was the first replication basically of that work. And we scaled their work to the 1 billion parameter size because in their paper, they only showed it was working until 400 million parameter model sizes. So we scaled it up to the 1B size. And then from there on, obviously did more research on the algorithm side of things, obviously. So we kind of realized you can very much also quantize those pseudo gradients. So usually your gradients are in 32-bit precision when you try to send them, and we got them down to 8-bit basically by quantizing those, and it was still working as well as you would send the 32-bit gradients. And that was one of the things on the algorithmic side, as well as also on the framework side. So we switched basically to our own decentralized training framework called Prime, where we basically built a stack on top of PyTorch for fault-tolerant training. So in that sense, a node can drop out of the training, and training is still continuing basically. It has a lot of great features in a sense. Happy to go into detail on some of the things. Like for example, you can join with a node, obviously, in the middle of the training one, right? then it peer-to-peer downloads the weights from the other node in the network, basically, right? And yes, able to contribute then to the next outer step, basically with 0 gradients at the beginning, and then it actually starts contributing, right? So I think the fault tolerant part, as well as the onboarding, offboarding dynamically, is like, yeah, one of the main features of it, as well as pretty good efficiency. But yeah, happy to go into more detail with questions.
So we did here in San Francisco a reading group on DLOC. So I had to dive very deep into all the results. We did DLOC, and there's a second one, DPACO, right? So I guess we can talk about that a little later. But for DLOC, generally, I was a little disappointed with the baselines they chose to report against. I think in many cases, the baseline I would want to see was missing, right? So in this regard, you only had 2 baselines, of which one I think was the most meaningful one, right? Which is training in data parallel fashion with the same number of replicas, right? But I think DeepMind paper had like the basic report against that one, but everything else was against a single replica, which is a very weird baseline. Like obviously it performs worse. It's right. But I think a very interesting question is, so in your report you show that the DLOC is slightly worse, right, than data parallel. But the question is, what would be the size of the like what should be the batch size for DLOC to precisely match for replicas of data parallel?
It's a good question, right? And how I think about it is, like, obviously, if you want to match then the data parallel baseline, like in our report, maybe to go back to that, we matched the data parallel baseline at a later stage in training, basically, right? So right now it seems like the convergence at the initial phase with a lot of steps basically is a bit worse, right? So
you're saying eventually they converge with the same number of replicas. That's great.
So that's one of the things, as well as it is all like a bit depending on the number of inner steps you already choose, right? Like 500 inner steps are quite a huge number, especially if we do int8 quantization on it, right? We can get down the communication requirements by 2000, right? And for a lot of the things we didn't need that, right? For our Intellect 1 run, for example, right, we're fine with 100 steps basically doing int8 quantization. So we have a reduction of 400 basically, and we're running pretty efficiently across the whole world, right? Between all those nodes. So pretty comparable to decentralized training, right? Obviously, unfortunately, don't have a baseline for that one. If anybody want to sponsor it, happy to run a baseline experiment. But at specific scale, it gets too expensive in a sense, right?
So I have a couple technical questions. Maybe they answered in the report. I didn't read it very carefully, but one is so the actual number you used for Intellect 1 is 500, right? The number of steps.
No, 100 inner steps. So 100 inner steps with our quantization technique. So we have 400 x reduction basically in training.
And the optimizer used the same as in paper, like Adam internally, master of momentum.
Exactly. We didn't want to like take risk basically on that front, but
But you don't have, like in the original paper, they train in like a single replica for the first several steps. You don't do that, right?
That's a good question. Like we didn't do that. No, we started randomly initialized from scratch basically, right? We've been obviously in contact with different folks that have been doing stuff on DLOC or with us himself, right? And he was also showing it works also if you just start from scratch. Not sure why he did it in the paper to start from the 24K steps checkpointers and blazes.
I think in the paper they showed that it doesn't matter. So their point was more like, hey, if you only do one replica, you save some compute. But I don't know if the complexity of this extra step, justifies not using compute for 24,000 steps, which is negligible anyway. Okay, so let's dive a little deeper into Intellect 1. So I guess generally the something. So we discussed with Illia a lot the idea of training a model in a decentralized fashion. And there's a couple interesting things. One is that training model is easier than training a good model, right? And I wonder how you approached choosing. Like, I presume you didn't do a lot of like grid search and whatnot for hyperparameters, right? So how did you approach choosing the particular model architecture, hyperparameters, and data composition, right? So like, for example, I see that you use 55% of where did I see it? Yeah. So FineWeb EDU, right? So I guess one interesting question is what is FineWeb EDU, and how did you approach choosing that data composition?
Yeah, happy to share. About the data composition, we had help from Hugging Face. They were interested in obviously what we are doing here, right? And propose this like kind of data set we are going for right now. And yeah, FineWeb Edu is one of their latest data sets. At least in terms of like benchmarks performance and stuff like this, one of the best data sets out there for doing pre-training basically, right? As well as we put a lot of other data sets into the mix just to have a bit more variety, right? We had the stack in there, which is like a coding data set, right? We had a open web math in there, so more like a math data set, right? As well as, let me guess, DCLM or something like this. I think it's from Apple. Some of the other open source data sets that came out. So there's been a lot of progress actually in the open source world to just create better pre-training data sets that wasn't really around like a couple of years ago. When we all were training on the pile by Eleuther.
So I don't know Stack V2, but I was playing with Stack V1. I remember Stack V1 was just individual files, so you wouldn't get much in terms of coding context. I don't know if V2 is solving it or if it's similar. And FineWeb has no code, right?
Probably not as much, no. Or very little.
I was going through FineWeb with the filter that would say, hey, only show me the things that have line break space, which I think is a relatively simple filter for code. And like I went through the first 2% and I didn't find any. I think that's sufficiently good indication. It probably doesn't. I mean, they probably intentionally filtered it out as out of not a target use case, I guess.
Makes sense, yeah. But maybe to share a bit more there, right, on the dataset side, as well as obviously the Intellect 1 model. It was the first release to basically show it's possible, right, to train efficiently a 10 billion parameter model around the world, right? Obviously, we want to make it a decent model, right? We trained on a decent data set, obviously. We trained on a full, 1 trillion tokens, right? Obviously, the current Llama series and a lot of the other models basically out there in the open source right now are trained on a lot more tokens, right? They get better performance. We just want to show, hey, you train on 1 trillion tokens in a decentralized fashion, such a model, and you get a model that you would expect to be of this quality in a sense, right? So that was the plan for Intellect 1, but obviously for Intellect 2, we have a lot more planned there. Decentralized training needs to show that it can actually train a frontier model, obviously, right? And that's the moment like all the more engineering challenges are currently solved, right? We had a lot of issues with fault tolerance in the training, obviously, right? Where we fix stuff in production in a sense, right? To fix all the failure modes for fault tolerant C. Where it was still failing, right? And then at the end of the training one, I think we got a pretty decent stack now of people being able to onboard to the training one as well as offboard.
Yeah. And it's like architecture-wise, it just it's like Llama, right? Like GEGLU, RMS norm.
Exactly. We took the Llama 3 architecture and just added a couple more layers basically to the Llama 3 8B one, same tokenizer. So didn't really innovate there, but also very excited, obviously, on all the architecture improvements. But for the initial one, didn't want to take the risk to that it could be failing because of those kind of reasons to change a different architecture.
Yeah, but and it's not mixture of experts, right? It's
not a mixture of experts, not a Deepak way.
Yeah. So I'm looking at the table with the comparison, right? So it's and specifically Intellect 1 versus Llamas. I think Llamas is the most interesting benchmark, at least because I actually don't know Some of the other models, I don't know, maybe some of them are more exciting. But Llama is, it's an industry standard more or less. And so on certain benchmark, I would say my vision of what I see is that on most benchmarks, it's a little worse than 7B, right? Which I guess is still pretty good for the first model. But interestingly, on grade school math, it is outperforming even the 13B Llama, which is, it could be, I guess, because of 5% data mix. But it's interesting, right? So it's already outperforming on some benchmarks.
Yeah, for sure. There could be a reason. FineWeb Edu, I think, has a lot of like great, more educational data in there. So I would expect it to be good at grade school math in a sense, right? So that could be one of the reasons too. But yeah, in general, we were pretty happy with the benchmarks results that was scaling at least to that size in a sense, right? All the other models we compared that to on the Llama 2 series at least, right? Were trained on like 2 trillion tokens, right? So
they also trained one day. That's a good point, right? I guess if Prime Intellect was trained for twice as long, that would be right. But even like I guess Llama has like 60 people centralized cluster. It's like I think for the first model, even if it's underperforming, not because of the smaller number of tokens, it's still an outstanding result and a pretty good proof that the approach is viable, which I think is quite important. I think generally it's my very big. I don't know if I'm fully convinced that scale will continue, right? But if it does continue, the fact that only 3 entities in the world can train a 1 trillion parameter model is not where we want to be as a society, right? If so I think it's the effort to make it work right now is the best time was last year, but the second best time is right now.
Exactly. Yeah.
So something else which is interesting that I wanted to ask is I spent quite a bit of time last year training large language models, and one problem I was fighting with, which there's very little information online about fighting it. It's mentioned as an existing problem, but not much in terms of a solution. Spikes. So I wonder if you observed spikes and how you dealt with them, if you did.
Yeah, honestly, we didn't have to. Let me think about it. But I don't think we had any like lost spike basically in the current training run, right? Which was interesting. Like that's one of the things you need to test in like a large scale training run, right? It could have very much happened that DLOC is not as good in terms of training stability in a sense, right? That it could have like, especially in the end of training, basically have lost spikes, right? Where you just have to restart from a checkpoint and hope that it is not happening again in a sense, right? We obviously integrated some research on top of actually the Llama 3 architecture with the set loss that one of our researchers is a huge fan of for like observing how stable the training is in a sense, right? Where you can basically identify lost spikes earlier than they would happen basically. So we implemented that one, looked all good. Didn't look like it's gonna have a lost spike, right? But yeah.
Yeah, I guess the reason I thought of a lost spike is that there is like a little spike in the training, but now that I look at the picture, that's because the data composition has changed.
That's a good point.
Okay.
At the end of training, so basically, maybe to share there a bit, what we went with the learning rate scheduler. So usually when you train your model, you have to define in the beginning how many tokens are you training on. So you have a specific learning rate scheduler that is just annealing the learning rate to 0 at the end of the training, right? And like a cosine curve. And what we did in the training one from like research from also, I guess, from Hugging Face, but also other organizations released this over the last couple months that they've been training models like this, is basically to have a constant learning rate after a warm-up phase, where you can basically then decide at which point do you actually want to do an annealing phase to actually get the model anneal the learning rate to 0. But you basically have the option to train on as many tokens as you want, right? And we obviously publish the checkpoint and stuff like this, right? So if anybody want to take it, continue training, they can do it, right?
Yeah.
As well as like us, obviously we have a bit more focus on the Intellect 2 direction right now, but yeah, theoretically you could just continue training basically indefinitely, or how big the data set is. Yeah.
And so with Intellect 2, what are the big changes? Like, is it different? Is it the same architecture? Is it the data set composition, or what are you guys looking into?
What we're looking into is, fixing some of the limitations we have right now with the local run, right? So one of the things, obviously, we want to scale to bigger model sizes, right? So the current network bandwidth is actually not the limiting factor in a sense. In some regions, it's more also about the memory requirements you have, right? Like if you want to train a 10 billion parameter model on an H100 node, that's almost already the limit, right, of what you can train on an H100 node if you shard like your parameters, gradients, and optimizers, right? So we need a way to use less memory, right? There are different optimizers for doing this, as well as like more the galore type research approaches, right? So we've been exploring over the last couple of months all of those research directions to make that possible. As well as the other component is to scale to more providers, more compute contributors, right? So right now, DLOC has diminishing returns after like 8 to 16, or in our case, we've been running on up to 14 nodes, right? And we've been working on research approaches and have a paper coming up to actually make it possible to scale to a lot more providers, right? Or compute providers. So that's one of the things we are trying to tackle, right? The memory requirements as well as the number of compute contributors we can scale to, and then we want to train a frontier model for the next one, right? So it's not about only the model, right, and the local scales, but we also need to make progress on the data set size and a lot of other components. So we've been exploring a bit in the large-scale strategic data generation domain, and have some upcoming releases on that front, basically. But yeah, that's all the research direction we've been basically exploring for an Intellect 2 launch.
Yeah. So I guess one interesting question here is that, we discussed earlier that in your original paper that you published in October, I guess, or earlier, DLOC was not doing as well as data parallel, right? But you're saying that, down the, with a large number of tokens, it converged. So there's a good chance that, like if you run DLOC with a 30 replicas, that it's doing poorly at the beginning, but maybe, long term it does as well as the data parallel with 30 replicas. So it's something that is very hard to experiment with without actually running a long run. So it's but it could be that DLOC actually just, it could be that it just scales to larger number of replicas. We just don't know it yet without running an expensive experiment. But also something I wanted to ask is, what in the current run, a single node, is it a single machine with 8 H100s, or is it like a small cluster? I see.
Yeah, right now it's a H100 node basically as a single worker. So we made it open for anybody to basically contribute GPU resources through the platform. Basically, they could just launch an instance there, right? As well as everybody else that provided compute, like a Hugging Face, obviously had their own compute resources to put into the training one, right?
So in the short term, right? Like let's say we want to train a 70 billion parameter model, right? And you mentioned that 10 billion is sort of at the limit of what fits on a single machine, right? So in the short term, something that presumably will work is that you say, hey, a single node now is not a machine. It's a small cluster of 8 machines, because majority of providers give you like if you go to Lambda or like any of them, they give you small clusters with interconnect, right? So it wouldn't be impossible to imagine. Especially,
like, you could do it right now if you want to do a launch basically of a 7 billion parameter model, decentralized in the same setting that we got, in a sense, right? Like we had also like single nodes in data centers where there wasn't other nodes available because we were running on spot instances there or something like this, right? But for the general use case, there's a lot of data centers with more 8 H100s, right? Which got interconnects, and that's also one of the reasons why this approach is especially interesting for the big labs in a sense, right? It's not only for like the open source community, right? Training across their different smaller clusters, right? It's one of the things you could use it for, but also for the big labs to train across like 4 to maybe 16 different data centers that they got, right?
Yeah, exactly. Like especially Google, right? That has historically has a lot of locations with TPUs, right? And I think so. So I see 112. I will not be able to divide it by 8 on my head. I suspect it is 14, right?
14. Yeah.
Yeah. Right. So right now you use 14 replicas, right? So like finding 14 clusters of 8 machines is extremely doable, right? So it's so like short term there is a simpler solution, because I think the Paco results were very underwhelming, right? So it's presented as a super cool solution, but once you start like running math in your head, you realize that the Paco is very data inefficient, which I guess is sort of expected, right? Given that it's actually training a much smaller model than it's more like a mixture of experts.
Yeah,
right.
like I'm still like interested obviously in the more mixture of expert type of ways, right, on how we can train decentralized, right? I'm not sure if it's a approach they've been going for there with like a sequence level mixture of expert, right? So what you usually have is you when you train your mixture of expert, right, you route per token, and it's actually extremely like communication intensive, right? And they route per sequence, right? To like different experts, which made it possible to train this decentralized. But yeah, also not 100% convinced yet that's the way if this is actually producing the best model that is possible and is not worse than a normal mixture of expert.
Yeah, that's yeah. So I noticed when you were talking about ideas for Prime Intellect 2, you didn't mention that direction.
Yeah. Okay. I think it's more about the novel like architectures. Obviously, we've been launching something like a nano GPT challenge, basically, or like somebody did, and we created a leaderboard for it, right? Which is an interesting challenge to basically get a better model performance. With less tokens, right? Or like gets the same model performance on like a GPT-2 benchmark to the same loss on FineWeb Edu to on just less tokens, right? So those are more the approaches we've been interested in to innovate for on Intellect 2.
Yeah. What is the timeline? When do you guys? Oh, I guess not even just what's the timeline. The first question is, are you training something right now? Right? You have those resources. Are they utilized, or are they waiting for Intellect 2?
We've always we are always running ablations in a sense, right? To make sure what we want to train next, right? But we don't have Intellect 2 running right now. I can say that much.
Yeah. So I guess couple interesting. So at some point I want to discuss the step 4 of the master plan. I think it sounds very exciting. But before we even go there, right? So like training a large model is very expensive, right? So like let's say if you want to train a 400B, that will be something that is extremely expensive, right? It's like it used to cost $100 million. Maybe it's cheaper now. H100s were continuously getting cheaper, but it's still at least an 8-digit number, right? So it's what is your thinking in terms of like, are you thinking of monetizing the models eventually, or are you thinking of it more as humanity pooling resources to create public good without an expectation of the returns? Like, how do you think of the business model?
That's basically the 2 dimensions we see on this too, right? Like either you're on the front of like monetizable open source models, which is an interesting research direction. I'm happy that people are exploring it in a sense, right? To make that possible. Seems interesting too. My current guess, or like how we see it basically, is that everything will be commoditized in a sense, right? What we are doing here, we commoditize compute with our compute exchange, right? To always give you access to the cheapest compute resources, make completely commoditized, as well as on the intelligence side, right? like the models that are out there seem to be becoming commoditized in a sense too, right? And we see it more as like a public good of people coming together, want to pool resources to actually create their state-of-the-art models, and will be the greatest public good in history to have like open source AGI.
Yeah. Okay. So you're thinking more of like people just like voluntarily contributing compute into a very large cluster.
Exactly. Like I rather think that it's going to be more like a public good than being monetizable, but happy to be proven wrong and people figure out how to monetize open source models in a way. I'm maybe to give a caveat there, on different directions, I'm more bullish on monetization, right? So there are a lot of foundation model use cases where it seems reasonable to monetize the model layer. So for example, for like a large scale scientific foundation models, which we've been really interested in with my background, but also my co-founder's background in the DeSci space, to innovate a lot there. I think there's a lot of possibility for monetization. But on the frontier model lab side, it seems to be a lot more commoditized in a sense, right? For scientific foundation models or like any kinds of other models in this direction, robotic foundation model would be interesting. We've been training a metagenomic foundation model for pandemic prevention that's going to come out soon, which is also very easy to train in a decentralized fashion in a sense, right? So for those kind of use cases, I think we would love to explore that on the monetization side.
Yeah. What are the so you mentioned some research on monetization side. I don't know if you have some particular favorite approaches that you heard of.
I think some of the ones are to actually make it possible that not everybody gets the weights of the model, right? That's one of the approaches I've been hearing over the last couple of months, right? I really wonder how that works out in like still having the best perform model and also the fastest inference. People want to have fast inference, obviously, right? And it can't be expensive there. So we've been not following or like exploring that closely. As well as all the fingerprinting type solutions, right? People have been proposing. Not my area of expertise.
Yeah. I was thinking a lot about it because I think, as I mentioned, I'm primarily interested in the situation where the models continue being bigger and bigger and better. Even though I'm not fully convinced that that's what will happen, there's definitely not a trivial probability of that happening, right? And so, how do we make sure that the open source community continuously has, resources to train those models, right? Especially if they require, hundreds of thousands of H100s, then does the community have to even collectively access to those resources, right? And monetization, I was very interested in it, and I think one of the most interesting approaches that we're looking into is H100s have trusted execution environments, meaning that you can run code without the host seeing what's happening there, or like anyone seeing, right? And H100s has an overhead of like 30%, I think people say, between 10 and 30. But B100s will not have any overhead, meaning that you can run in a trusted execution environment as fast as if it was not, right? And so there's this idea of training a model in such a way that nobody ever sees the weights. They're always encrypted, right? And then the model would only do inference for you if you open a payment channel and pay for it, right? So anyone can copy it to their machine, right? You don't have to trust anyone. You can, build your own rig, bring the model locally, cut the internet, you use the QR code to send the payment channel, so it's like fully isolated, but you still have to pay to use it. So I think that's a very exciting direction.
Definitely sounds interesting, and excited to see some research there. Hopefully the supply of the next generation of NVIDIA chips is going to be even greater in a sense, right? That you could do it on any B100 or B200. That would definitely solve a lot of our issues too. So excited for it.
Yeah. And it was very fascinating, right? H100s came out last year, right? And like by the end of 2024, it's a commodity, as you mentioned, right? Like I can go to GPUlist.io, which is it's like an aggregator of all those providers, right? And it's like, $2 per GPU is like there's a lot of them at this
It definitely
price
is,
point.
but especially on the large scale cluster size, there's still so much
Mm.
like difference in reliability of the providers, right? So the REC.AI folks had this great paper of like showing like 100x difference in terms of reliability on the clusters they've been running on, right? So I think we have to solve the fault tolerant part on the software stack if NVIDIA
Yeah.
doesn't solve it on the hardware side, right? Where they're obviously still the best, obviously, in their game, but they still have issues, right? And the providers have
Yeah.
issues, and
Yeah.
to fix it on the fault tolerant side is probably the way to go for the next couple of years.
Yeah. And I don't think NVIDIA is investing much into that because people already used to the fact that NVIDIA GPUs fail in a variety of ways, and everybody who trains at large scale already has mitigations for it.
Yeah.
In one way or another. Okay, I think the most interesting thing, which I left for the end, is the step 4 of the master plan, which is actually one thing I wanted to mention is that I think of Prime Intellect as I don't know. I mean, you guys want to build a decentralized protocol, so I think of it as a somewhat in this crypto anarchy, set of companies. And it's quite surprising to see a company saying, "Hey guys, we are the first step of master plan, and we have more than one." Right, and then check 2 months later, and you're not at the first step. You're further along. That doesn't happen very often in the right. So I think that's a very that's a pretty cool speed at which you move to your master plan, right? So that's a pretty good indication that step 4 will happen, at some point. So I would love you to talk more about your vision for Prime Intellect in the future.
I mean, we structured the master plan in a sense like this way because we obviously have to solve a lot of the research challenges right now to even get to like more like a protocol-based system where we can incentivize people to contribute GPU resources to train like frontier models and create the greatest public good in history to build open source AGI, as well as like making progress on science and stuff like this, right? With scientific foundation models and so on that's been being trained on people contributing GPU resources. So that's why we structured the way like the master plan like this. Obviously, we want to solve a lot of the fundamental research challenges right now, right? Scaling Intellect 2 to like the largest model, as well as like making more the trustless compute component work, right? So we've been exploring different components on with the least amount of overhead in a sense to enable people to provide compute resources where you can verify they are not sending malicious gradients, as well as that it's actually an H100 node that they are providing, right? So we are still on the way. I have to solve some of those like trustless compute challenges in a sense, as well as like proving with Intellect 2 that we can actually train a frontier model, right? And then we'll move ever closer to the last stage of our master plan. And
So a lot of that, if you trust NVIDIA, which we sort of have to, a lot of that can be achieved with the trusted execution environments, in the sense that, like NVIDIA will send you an attestation that this is H100s, and if you run the code inside of the TE, you know that the gradients they send you are correct. So I think short term, this is the most viable solution. Even though
it is, but right now there's a lot of like supply shortage in that sense, right? We've been talking to a lot of different providers that we have on our platform, obviously, and those unfortunately have like not the expertise to actually set up like an H100 node with a trusted execution environment, or don't have the specific like CPU chip you need with actually enabling that, right? The CPU extension.
Specifically, for TDX, you need the 5th generation Intel processor, and we talked to a lot of providers, and in fact, it is not something people have today. Exabits will have some of them in the future, like in a very short future, but that's, I mean, having one provider is precisely opposite of having.
This is a supply issue right now. So we've been thinking more about more approaches in terms of like staking and slashing and stuff like this, right? Where you have a lot to lose basically, game theoretically, if you send malicious gradients or provide compute resources that are not as And not the ones that we need for the 21, right? So
that's obviously a more standard approach. But my thinking with TDX is that, first of all, it will probably change, right? Like same as what happened to H100s, which, like 2 years ago, they didn't exist, and now they quite abundant. But also for people who will be joining, especially people who will be building rigs in the future, if they know that fifth generation Intel processor gives them more opportunities to use it.
That's definitely bullish on the future there. If we want to launch something early next year, there's probably not as much supply to actually do an intellectual launch on such a system, as well as like obviously right now we've been still limited to homogeneous hardware, right? We've just been running on H100 nodes. But we also are working on approaches to make our DLOC work and more to be able to use heterogeneous compute, right? So we will still mainly be focused on more the data center GPU, just because of the rerun requirements we got for actually training state-of-the-art models, right? But at least like it's still good to train on A100s, right? So there's nothing wrong with that. A lot of researchers don't want to, but there's no reason to also include A100s in the training one, multiple nodes there and stuff like this.
And A100 also has 80 gigabytes of memory, right? Yep. So it's like the same size of the model will fit. It's just the number of steps you can do is smaller.
Exactly. Yeah.
We didn't mention in the DLOC paper what happens if in the same amount of time, So you cannot have the number of steps constant anymore, right? Now it has to be variable, presumably, right?
Yeah,
because if you like A100, I cannot do 100 steps at the same time.
Exactly. Or you run on two A100s and then you are roughly the same time, but that's not what we went with. It needs to be a more like asynchronous approach, right? Right now it's very synchronous, right? They all synchronize after 500 steps. And yeah, we've been very interested in how to make DLOC work asynchronous. There's also a paper actually from Google DeepMind that did DLOC asynchronous, right? But also just scaled it to I think only 150 million parameters and not more, and had to do a lot of tricks actually to make it work asynchronous. But yeah, we are thinking about like an easy approach there.
So actually, a couple more interesting questions. One is, like the number of steps you take between gradient synchronization. What is it? Like, how does it map into the real-time clock? Like, how frequently the gradient synchronization happens in terms of like seconds?
Oh yeah. So for our Intellect 1 run, where we were syncing every 100 steps, right? We've been syncing every 40 minutes. So they were running completely independently on those different islands for 40 minutes. And then, depending on our configuration, we had different synchronization times. So we've realized, for example, in the US, you have pretty fast interconnect between all those nodes, right? So we had a 4 gigabit interconnect between all the US nodes that we got like all over the US. So we've been the all reduce basically of all the different nodes in the US took 1 minute then. And then we in the training one we added Europe, right? So we had some nodes in Sweden and Finland, I believe. And then our all reduced time went down to 5 minutes, right? Which was still pretty efficient, right? We trained for 40 minutes and then we synced for 5 minutes, which is still acceptable, right? And then I think when we added Asia, some Singapore nodes and Indian nodes, we were at 6 minutes or reduced time on average. So that's about the compute efficiency you can expect there with 100 steps.
Yeah, is all reduced taking geography into consideration? Like, is it more efficient to all reduce all in US than all in Asia, and then like the 4-way, or that's not happening yet?
That's the plan. It didn't happen yet. So right now what we do is like a literally ring all reduce. So we've been literally when we like all reduce between all those different locations. We've been doing a ring around the whole world. But obviously there are even more efficient ways to do it. Like one of the things we could sync more often in like a continent, for example, or generally where you have fast interconnect. Sometimes it's actually pretty weird. Like we had some connections to Europe that were extremely fast because some kind of internet routing internet routing reason, right? And yes, fundamentally, usually it's like in a continent, you're faster between the nodes, right? So there's definitely ways to make use of that for our next run.
Yeah. And do you know already how big Intellect 2 will be?
Let's see. Let's see how much progress we make. Obviously, on the on the rerun side size, how much we can actually fit into a node, right? That's one of the things, as well as we want to make progress, not only do data parallel training, obviously, which we do right now, right, which is fundamentally limited. You have to do the whole training on a node, but actually split up the model with like pipeline parallelism, for example, right? So there we could actually scale to a lot bigger sizes, but it's also another engineering challenge that we have to solve until Intellect 2.
Yeah. Oh, so you think that will already be? You're already expecting to have progress on that front by the Intellect 2?
It's a good question if we need it. Like we have 2 streams basically going on there right now, right? Like you could either like work on approaches to reduce the VRAM requirements on a node, right? To actually train your model on a node, like larger models on one node, or you can split up the model, right? And do pipeline parallel training. Great researchers from Together AI, Max Verbinin, who's been like fundamentally inventing the whole field of decentralized training, right? He's been working with us on the Intellect 2, advising us for research there. And he has this great paper on Swarm, which it's like a pipeline parallel decentralized training approach, right? Which nobody has scaled yet for some reason. So I'm excited. I would love to, if some people want to do open source contribution work to our Prime repo or whatever else, right? In terms of like making pipeline parallel training work across the world, right? That would be amazing. And yes, there's a lot of potential, I guess, into scaling the Swarm algorithm.
Whose paper is that?
Max Verbinin is a researcher who has been doing his PhD actually in decentralized training, right? So a lot of the fundamental work in terms of this research direction is coming from him.
Yeah. Okay, cool. We still have 5 more minutes, give or take. So I wanted to also briefly talk about the post training. So I see it's done by Arkia. I don't know if Arkia is completely separate entity. If you just guys work with them, or what is the relationship there? Whose compute it is? Who's incentive, etc.
RCI is a really good friends of us, basically, that are one of the leading orgs, I would say, on doing post training of those foundation models, right? So they have those RC supernova models, which are pretty popular, and have a whole team like just specialized on post training of base models, or even continuous post training of instruction tube models, right? Really grateful for their support basically on the Intellect 1 release. They actually made it possible that the space model you could actually chat with the model, right? Which we didn't in-house have the expertise to do it as quickly as they did. So we sent them the weights on the day when the Intellect 1 run was done, right? And they immediately started cooking on it, and had a pretty good model at the end of the week then, which we deployed in a chat form. Everybody could chat with it, right? As well as like open source it, right? They did a bunch of different approaches. So one of the things they always do on those models that they innovated in a sense, is the merge kit work. So basically merging different open source fine-tuning models, right, to get one better model out of it, right? So that's also what they've done on our Intellect 1 run. So doing a bunch of different fine-tunes basically, and then merging all of those, the best ones at the end, to get the best model out of it.
Yeah. So if people want to chat with the Intellect 1, where do they go?
They go on chat.primeintellect.ai.
I see. Yeah. It was. I didn't see it in the tweet storm, so it's well hidden.
Yeah, it was a long tweet storm.
Yeah. Okay, that's and where is Prime Intellect itself distributed, or where you guys located?
Most of the people are in San Francisco. So yeah, most of the people are here, but obviously we are happy to have a lot of like distributed community members in a sense, right? That can work on different research challenges, right? So yeah, if anybody interested, we have a lot of challenges to solve, and hope is an interesting research problem to work on.
Yeah. Okay, that was a very fun discussion. I don't know if we discussed everything. If there's something I didn't ask that you think is important in the
I
content.
think you asked, yeah, great question. I wasn't even expecting such a technical discussion, so that's amazing that you went so deep on like all the DLOC work previously before too. So really enjoyed it, and that I could share some of the research stuff here too.
Yeah, and we can put like any links below the video to the relevant stuff. So it's yeah, but yeah, I think this is one of the most exciting directions or the decentralized community can and should take today. So it's exciting that there's actually someone who's working on it actively. Yeah, and so yeah, let's see how Intellect 2 when when it comes out, and yeah, everybody who wants to play today, it's chat.primeintellect.ai, right?
Exactly.
Yeah.
Yeah.
Okay. Yeah.
Amazing.
Okay.
Thank you.
Thanks a lot for joining us today.
Thanks, Alex.